In this video, we are going to see an example on alternative voltage summation. So here we have a circuit right here with 3 loops, and here we are going to see how to set up equations and solve problem for the questions like this. So first of all, you have to know how to set the equation using KVL and KCL. Here I didn't put some values for the voltage, so here let's say this is 5, let's say this one is 10, and let's say this is already 20, and then what else? So everything else is there. And first we have to know the direction of the currents. If you look at the plus minus sign across the resistor, you can determine the direction. So for example, if you look at this one here below 1K, this is plus minus, and the current flows from higher potential to the lower potential. So plus minus mean it's moving from this to this. So let's call this one I1 over here, and here this is minus plus, which means the current is flowing from opposite direction. So it is in this direction, we can call this I2. And here plus minus, which means it is in this direction, we can call this I3. And then here if I look at this one here, minus plus, so and it's the current is already here, because if the currents are if the resistors are in series, the same currents flow through all of them, because currents are same in series. So all the series resistors have the same current. So this I2 is the exact same thing flowing here as well. And here if we look at this one here, plus minus, so highest to lowest, so this is in this direction, this is, we can call this I4. And then if you look at this one here, minus plus, so Eugene plus to minus mean this direction, so we can call this one I5. And did we miss anything? Because this is going to be the same current here as well, because these are in series, so it's going to be the exact same current. And I didn't put this one here, so here plus to minus, so we can say this direction I6. Now we have all the currents and the directions. And also you have to know that if you have voltage, the longest sign is a plus and the smallest sign is a minus. So here this is plus minus, minus plus here, and this one is plus minus here, and that is it. Now we can set up the equation. So if I say this is loop number 1, and if I take the direction to be clockwise, you can either take clockwise or counterclockwise. So I'm going to do this one clockwise, and I can make this one counterclockwise, and I can do the counterclockwise. It doesn't matter. You can do this one counterclockwise, this one clockwise, this one clockwise or counterclockwise. It's your choice. All of them give the same answer. So once you take the direction, then we can go ahead and create our equation. So let's call this one loop number 1, loop number 2, loop number 3. So if I take loop number 1, first of all, if I look at the, if I'm taking clockwise, anything minus to plus, if I think about minus to plus, that's a negative. So this is, if I take clockwise and look at this 5, this is going from minus plus, so this is a minus 5. And then if I look at this one plus to minus, so that's a plus. So that's the I1 current. V is equal to I times R, so I1 times the resistor 1K give the voltage here. So I1 times 1K over here. And then if I look at this one, plus to minus, so that's going to be a positive. And then I3 currents flowing through there, and then the resistor is 500, so I3 times 500. And then if I look at this one clockwise, this is minus to plus, so this is going to be negative. And then the current flowing through that is I6, and then resistor across that one is 4K. Okay, addition of all the voltage in a loop is equal to 0. That's the Kirchhoff's voltage law. So this should be equal to 0 right here. And if I look at loop 2, here I'm taking counterclockwise, so which means if I take this one here, this is counterclockwise, this is plus to minus, so this is I3 is going to be plus. And then the voltage across that is 500. And in the above one, I missed one thing, like I didn't put the 10 here, so the 10 is minus to plus, so we should put a minus 10 in the above equation as well. There should be a minus 10 voltage as well, because here we have voltage. So this is I3 times 500, and then if I take counterclockwise, this is minus plus, so this is minus 10 here. And then if I take counterclockwise, this is minus plus, so this is going to be minus, and then the current flowing through this is I4, and the resistance across this is 5k. And then if I take counterclockwise, this is plus minus, then it's the exact same current I2 here as well, because these are in series. So this is going to be plus I2 over here, and then multiply by the resistance across this, that's 200. And then if I take counterclockwise, then this is minus 2 plus, so this is minus 20 over here. And then minus 2 plus, this is if I take counterclockwise, this is plus to minus, so that's going to be a plus I2 times 2k, and all together should be equal to 0. That's KVL. And if I take loop 3 over here, for this one I'm taking clockwise, so which means if I look at this one, this is minus 2 plus, so that's going to be minus I4 times the resistance across that is 5k. And then again here this is plus to minus, the same current flow here and here, so this is also I5 current, so this is going to be I5 times 5k. And if I look at this one here, clockwise plus to minus, so this is plus, then same current I5 times 400. And then if I look at clockwise, then this is plus to minus, so plus I6 times 4k, all should be equal to 0. So these are 3 KVL equations from 3 loops right here. Then next thing we can do is analyze the KCL. The Kirchhoff's current law can be analyzed in each node. So wherever you see a junction with multiple current flowing, that's a node. So here this is a node. Let me use some different color over here. So this is a node right here. Okay, and multiple currents. So if you look at this one, this is only I1 flowing. This is only I2. So these are not nodes. You have to look at the junction. There are multiple currents. So here this is a junction because this one meets I5, I6, I1, and this is a junction I3, I6, I4 meets, and this is a junction I4, I2, and I5 meets. So these 4 are junctions. So there can be 4 KCL equations also can be formed from this circuit. So first of all, if you look at this one, entering is plus, exiting is minus. So here I1 is entering, I2 is entering, I3 is exiting. So I1 plus I2 minus I3 should be equal to 0, because Kirchhoff's current law says addition of all the current entering or exiting a node should be equal to 0. So if I add all of them, this should be equal to 0. So then if I look at this node right here, I6 is entering, I4 is entering, I3 is entering. So all of them are entering. I3 plus I6 plus I4, all of them should be equal to 0. And then if I look at this node here I1 is exiting, I5 is entering, I6 is exiting. So I5 is entering, so that's plus, then I6 is exiting, minus, and I1 also exiting, so that's minus. That's equal to 0. And if I look at this node here, I2 is exiting, I4 is exiting, I5 is exiting, all of them are exiting, so minus I5, minus I4, minus I2 should be equal to 0. So these are the 4 current equation we can create from that. So here 3 unknown, 4 equation. Here we have 6 unknown. So totally we have 6 unknown and 7 equations. So we can find it. We had, after this it's all math. You had to play around with this equation and find each current values and stuff. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel.